Hyaluronic acid fillers are pretty much a cornerstone of aesthetic medicine these days. They're the go-to for everything from smoothing out wrinkles to literally sculpting facial contours. And the market for them? It has just absolutely exploded. But with so many options out there, you gotta wonder, what's really going on inside that syringe? And when I say exploded, I mean it. Just to give you a sense of the scale we're talking about, in Europe alone, there are over 140 different hyaluronic acid, or HA, fillers that are approved for use. That's a massive, massive toolkit for any practitioner. Which, of course, brings us to the big question, right? Aren't they all just kind of the same thing? If not, what actually makes them so different? And how on earth does a clinician choose the right one for the right person and for the right part of the face? Well, it turns out the answer is all in the science.
So here's how we're going to break it all down. First, we'll look at why HA fillers became such a phenomenon in the first place. Then, we'll dive into the chemical magic that makes them work, a little something called cross-linking. After that, we'll explore the two key types of properties that define a filler, and we'll focus on the real power player, a thing called G'. We'll also get a sense of what the practitioner experience is. And finally, we'll see how all this science helps them pick the perfect tool for the job.
All right, let's jump in. First up, the filler boom. Now, hyaluronic acid isn't some weird foreign substance. It's actually a sugar molecule that's naturally found all over our bodies, especially in our skin. And it's a total superstar at holding on to water, which is what gives our skin that plump, hydrated, elastic feeling we all love. But here's the catch. The HA that our own bodies make has a really short life. It gets broken down and recycled in just a couple of days. And that's not exactly helpful if you want a filling effect that lasts, right? So for a dermal filler to actually work, that natural HA has to be modified. It needs to be turned into a durable gel that can stick around for many, many months, not just a few days. And that modification, the single most important process that makes all of modern fillers possible, is a chemical reaction called cross-linking. Seriously, this is where the magic happens. This is what transforms a simple liquid into a structural gel that can actually provide lift. The best way to think about it is like this. Imagine natural HA as just a bunch of individual, separate chains floating around. During cross-linking, a special linking agent is added, and it acts like little bridges, connecting all those separate chains together. The end result, it's not a bunch of loose chains anymore. It's a strong, resilient, interconnected net. And that net is the gel that gives us structure and volume. Okay, so here's the key takeaway from that. Not all of these nets are created equal. Not even close. Manufacturers can actually tweak that cross-linking process to create gels with very, very different characteristics. And to make sense of the huge variety of products out there, we can basically sort all those characteristics into two main groups.
So on one hand, you have what we call dynamic properties. This is all about performance, how the filler actually acts once it's in the face. We're talking about things like firmness, lift, and flexibility. It's what the patient ultimately sees and feels. But then, on the other hand, you have consistency properties. This is all about the practitioner's experience, how the gel behaves as it's being injected. Is it smooth? Is it predictable? That kind of thing is absolutely crucial for a precise and repeatable procedure.
Now, let's talk about the real star of the show when it comes to those dynamic or performance properties. It's probably the most talked about characteristic of any filler, a measurement called G'. G', which you'll see written as a G with a little prime symbol, is basically a scientific measure of a gel's stiffness. It tells you how well it can resist being squashed or pushed around. To put it really simply, it's a rating of how firm and structural the filler is. It's the key indicator of its strength and its lifting power. And G' exists on a whole spectrum. The absolute best way to get your head around it is with a simple kitchen analogy. Think of a low G' filler as being soft and flowy, kind of like honey. Now, a high G' filler is much, much firmer. It holds its shape, more like Jell-O. And as you can imagine, you wouldn't use honey and Jell-O for the same job. Well, it's the exact same for fillers in the face. And this shows you exactly how they're used. Those high G' fillers, our Jell-O, are perfect for deeper injections where you really need to build structure and create lift. Think about sculpting a cheekbone or defining a jawline. On the flip side, the low G' fillers, our honey, are soft, flexible, and much better for areas that move a lot, like the lips, or for smoothing out very fine superficial lines. And it turns out, G' can also give us a pretty good clue about how long a filler might last. As Dr. Rheology points out,
As a general rule, those firmer fillers with a higher G prime tend to be more resistant to breaking down in the body, so they often last longer than their softer, lower G prime cousins. So, that's performance. Now let's switch gears and go back to those consistency properties we mentioned earlier. This isn't about what the patient sees, but it's all about what the practitioner feels and why that is so critical for getting a great result. A huge factor here is something called extrusion force. That's just a fancy term for the amount of thumb pressure a doctor needs to apply to push the gel through a tiny needle. You want this to be incredibly smooth and predictable. I mean, if it's too hard to push or if it suddenly bursts out, it becomes really difficult to place that product with any kind of precision. And this is where the consistency of a brand really matters. Just imagine you're the practitioner for a second. With brand B, every single syringe in their line feels the same, smooth and predictable, whether it's a firm filler or a soft one. That predictability means control. Now look at brand A. The force needed is all over the place. That kind of inconsistency forces the injector to constantly guess and readjust their pressure, which is the last thing you want when precision is everything. And it doesn't stop there. Two other quick but crucial factors are water uptake, which is basically how much the filler will swell by drawing in water after it's injected, key for avoiding any surprises with swelling, and then there's particle size, which affects the texture. Is it silky smooth for fine lines, or is it a bit more robust for deeper structure? Both are vital for getting a predictable, natural-looking result. Okay, so we've got all these different scientific properties. How do manufacturers actually use this science to create these product lines with so many different options? Let's see how this all builds into a really sophisticated toolkit. This is really where the engineering comes into play. Different companies use their own patented technologies to get different results. One company might mix various sizes of HA molecules to create a whole family of fillers with a huge range of firmness levels. Another company might focus on preserving really long HA chains to make exceptionally strong lifting gels. And others engineer their gels to be super flexible so they move naturally when you smile or talk. Each technology is like a different recipe designed for a very specific purpose. So what's the bottom line here? The goal isn't to find the one single best filler on the market. That doesn't really exist. The goal is to have a diverse set of tools. A skilled practitioner understands these scientific properties, the G prime, the extrusion force, the technology behind it all, and they select the precise product needed to match a patient's anatomy, their skin quality, and their goals. It's all about precision. And all of this leaves us with a pretty fascinating question to think about for the future. As the science gets even more advanced, are we going to see this trend of specialization continue? Even more targeted fillers for every tiny little nuance of the face? Or could we one day see a single smart filler that can actually adapt its properties after it's been injected? It's a pretty cool question for the future of aesthetics.